We have 5 excellent presentations in this last session, and we have 5 mini presentation and 5 mini Q&A session after each presentation. Please use this Q&A session if you have a question. Without further delay, I would like to introduce our first speaker, Professor Ming-An Lee from National Taiwan Ocean University. Professor Lee will present his topic on climate change impact on the habitat shift of the immature albacore tuna in the southern Indian Ocean. Let us welcome him with a big applause.
Okay, thank you, Chairman. I'm Ming-An Lee from the National Taiwan Ocean University. Today, I would like to share my work about the project climate change impact on the habitat shift of the immature albacore tuna in the southern Indian Ocean. Next, please. For albacore it is well known as the long-fin tuna. It's a species of tuna due to its have a high economical important fish in the water trade industry. It is a source for the can industry. This species is also a topic of commercial and recreational fishery in temperate and tropical waters across the globe. Next, please. This slide shows the 5 major fishing grounds conduct from the Taiwan fishing industry since the 1960s. In the Indian Ocean, albacore is distributed mainly in the areas south of the 10 degrees south and is migrated seasonally between north and the south area in the south hemisphere. However, due to the climate change impact, so this species their habitat was paid attention. So this object was tried to examine the spatial habitat distribution of immature albacore. We try using the habitat suitable index model. And later we try to identify the climate change impact on the habitat shift of albacore in the southern Indian Ocean. Next, please. Actually, we try to correct 1 by 1 degrees the longline fisheries data from Taiwan overseas fishery in Development Council. We have the data about the fishing number, year, month, day, and fishing effort, like the fishing hooks, catch, and the related data from the 1998 to 2016, and then we try to do the measurement, the transfer from the catch to the CPV, catch per unit effort. It is a reductive index for the albacore source. We can use the catch calculated as the number individual per 1,000 hooks, and later we try to use the GAM module, try to remove the influence of like the latitude or longitude as the influence to the CPV. Next, please. And for the environmental data, we try to use the remote sensing data. From this slide, you can see we try to use the sea surface temperature, sea surface chlorophyll, and the sea surface high, sea surface salinity, and the mixed data depth, and the AD kinetic energy. And all the data was tried to match up with the the fishery data by one degree. And then we try to use the imperious HIS model, like the AMN, GMN, and the CPM module, based on the true climate model at RCP 2.6 and 8.5 scenarios in 2050 and 2100. Next, please. And our result, you can see this is the spatial variation of a standard CPV of immature abaco tuna in the Southern Indian Ocean from 1998 to 2016. And from this figure, you can see the high standard CPV will be located about 30 to 40 degrees south, and they can extend from the 40 degree east to about 110 degree east. Next, please. So this result is talk about habitat development model related to the environment factor. From this table, we compare the three HSI model. We can see the AMN, GMN, and the CPN. There's the adjust the R square and the AIC value based on the delta AIC. We decide to choose the GMM module with the three environment variable, include sea surface temperature, sea surface salinity, and 1 month of sea surface profile A data. And here we can see this module, they have a high adjust R square value of 0.98957. Next, please. Next, please. So this slide, maybe we can show there's the habitat data mapping with the monthly standard CPV. Actually, we are based on the early slide show the important environmental factor like the sea surface temperature and the salinity and the profile data. From the early slides show the optimal range of the temperature, salinity, and the profile for the abaco will be the 70.5 to 20 degrees Celsius and 35.3 to 35.9 PSU and 0.06 to 0.225 milligram per cubic meter respectively to the abaco's habitat. So we try to transfer this environmental data to the habitat. So this slide is the habitat compared to the standard CPV. From this data, we can see our result is much fit to our HIS model. So next, please. So we try to project our climate change data and compare our immature abaco's data. This slide is the projected climate change impact on HSI shift. From this figure in 2050 at the RCP 2.6 scenario, we can see the high HSI zone is about located in the 30 to 40 degree south area. And in the scenario RCP A2 point, the HSI's zone we hypothesis larger than 0.6 will be shifted to the south of the 35 degrees Celsius. And for the project the HSI model in 2100, we can see for the RCP 2.6 the scenario, the zone, habitat zone may be limited to between 30 to 35 degrees south and between 62 to 70 east in 2100. For the scenario RCP A2 point condition, the high HI zone will be reached to the south, about 40 degrees south in 2100. So next please. So we can confirm we develop HSI model and try also to project the climate change influence to the habitat model for albacore tuna. So this slide is show the shift in the location of optimal environmental parameter from April to August, from the 1998 to 2016 for sea surface temperature, salinity, and chlorophyll A deck 1 month. So from this figure, we can see the albacore actually they are prefer to stay warm sea surface range for regulate body temperature and minimize heat loss. And for salinity, we suppose it's also an important predictor because the increase in temperature of water will cause increase in the precipitation, which may be lower the salinity data. For the chlorophyll A patch, we see the maybe it's an indicator for the food availability. So in general, maybe they have a lag time, maybe 1 week or 2 weeks, maybe for feeding ground. So here we use the 1 month lag the chlorophyll data, and we find maybe it's a good indicator to predict the albacore's habitat. Next, please. Next week, okay. Next, and this just only show the latitude change of the optimal values of environmental parameter used our module for different time point. And here is we try to compare we use the optimal temperature like the system temperature in the indicator of 19 degrees Celsius, and then to compare our model to the predict the result in 2050 and 2100. So from this figure, maybe we can find their latitude change. Next, please. So this slide shows the location of HSI isopressed 9. Also is under the RCP 2.6 and the A25 scenarios. So here we just give an example to show from the left upper panel, this slide we can see the considerable habitat change was observed in 2050 under the RCP 2.6. And this area we can see the HSI larger than the 0.6, will be shipped to the 70 to 100 degree east, and between the 30 and the 35 degrees south in 250. And here is the interior is for the 2100 in and under the RCP 825 scenario. So here we can see here is the under the RCP 825 scenario, the area with an HSI larger than 0.6 was mainly concentrated in the 50 to 100 degree east in 2050, and maybe a slight shift to the east or west zone was also observed in 2100 years. Next, please. So it excludes the sea subtemperature and the salinity and the chlorophyll. Actually, some research suggests that maybe vertical structure like the thermal front is also important indicator. Like this figure, they show the in the right panel. It shows the apical vertical distribution related to the thermal front. So we can see the apical there's the taking depth distribution during their studies. It seems the significant difference at the daytime and the nighttime. So they suggest the thermal front maybe also important indicator. In future, these issues maybe is our need to attention. Next, please. So here's I give the shortly the conclusion. Our results suggest the feeding ground of immature abaco was mainly distributed in the area 30 to 40 degrees south, and 50 to 100 east in April to August. Even the peak and the lowest catch years were observed in 2004 and 2010. Actually, we based on the multi-spectrum the satellite data using the GMM model, GMM Habitat Suitability Index model, can provide useful information to identify the potential tuna habitat. So we can observe the potential habitat is associated with the some environment like the sea subtemperature will be range from the 70.5 to 20 degrees Celsius. For sea surface chlorophyll will be ranged from the 0.06 to 0.25 milligram per cubic meter. So no substandard shows the HSI larger than 0.6. The latitude shift was observed until 2050 under the RCP scenario. However, a shift to higher latitude was suggested in the high HSI zone in 2100. So this result suggests a high latitude migration of immature abaco tuna in the southern Indian Ocean because of impact of climate change. Thank you. This is my talk, and for your listening.
Okay, thank you very much, Dr. Lee, for your interesting presentation. As you guys know, the climate change is a really big issue nowadays. However, we are running out of time. I don't want to interrupt your presentation, so maybe we can get the the question after this session. Now we're moving on our second presentation. Our second presenter is Ms. Jie Xie from Shanghai Ocean University. The presentation is entitled Hematocyte Responses of the Oyster Exposed to Decycling Hypoxia and Salinity Change. Please welcome her with a big applause.
Thank you very much. Can you hear me clearly?
Yes, I can hear.
I'll ask down. Good afternoon, everyone. I'm Xie Zhe from Shanghai Ocean University, China, and I'm glad to make a presentation here about hematocyte response of Hong Kong oyster exposed to dicycline hypoxia and salinity change. And next, please. I'll divide 4 parts to talk about these things. Next, please. And next. First, maybe you have already known some species about oyster or not, like the Pacific oysters, the rock oysters, the Hong Kong oysters. I think oyster is delicious, and some of which are also the main species in Asia. They are the linkage between primary producer and senior consumer in food chain, and they are also regarded as a monitor or marker to assess the environmental stress. And next, and then in this section, we'll talk about the Hong Kong oyster, a famous species in Beihai, Guangxi province in China. And next, Beihai oyster in Chinese, Beihai Shenhao, has become a signature product. And next, as you can see, this 2 picture is the I took in the culture region. And next, as we all know, oyster culture is where salinity and dissolved oxygen always change owing to rainstorm, water exchange, water respiration, and some other factors. Or rather, water exchange results from freshwater input, exchange of currents, and the respiration of microorganisms can consume lots of oxygen at night, such as the macroalgae. You can see. Although such macroalgae can produce oxygen by day, but they also consume the oxygen at night. So we want to know whether both the factors, the salinity change and the dicycline hypoxia, also the means hypoxia at night, will impact the oyster and how to impact. And next, as for the immunity in bivalve, it strikes us that the main rules, hematocytes, should be affected a lot. Also, it is common that 2 factors always cause the synergistic effect, as the review concluded. And next, please. Next, therefore, we choose 35, 25, and 10 ppt salinity as represent high, normal, and low salinity, and choose 2 and 6 milligram per liter represent hypoxia and normal dissolved oxygen. In total, it was classified into 6 groups to expose for 14 days. After that, it also have a recovery for 3 days. We think this is a short-term recovery. We sampled the blood to measure such 7 parameters using flow cytometer after 1, 7, and 14 days, and also a recovery for 3 days. And next, please. With analysis, next, Here are some basic parameters of water and oyster. Next, please. First, we talk about the exposure period. During such period, from the PCA, PC1 divided the normal dissolved oxygen group and the hypoxia group. And this side, the left side, they are very round. This represents the normal dissolved oxygen, and the triangle represents the hypoxia groups. And next, okay, and the PC2 divided part of high salinity and low salinity. And as you can see from the histogram, the combined factors caused a negative correlation between, please go back, between the left side and the right side parameters. That means the HM, RS, and IN, three parameters have negative correlation with the THC, EST, and LSO parameters. But the pHa will not change significantly during the 14 exposure days. And next, please. Apart from the pHa with no significant change, on one hand, their cycling hypoxia decreased the THC, EST, and LSO. And next, where it increased the HM, RS, and MN. Also, you can see the low salinity seems to strengthen the effect from the hypoxia. And next, please. In conclusion, you can see the cycling hypoxia intensified the decrease and the increase of the HAMSAT parameters. Also, with the time going by, HAMSAT mortality increased in the 14-day exposure period. Also, the pHa was not affected significantly during the exposure period. Next, please. From the table, we can see next. The HAMSAT in Hong Kong oyster had significant responses to the hypoxia and the salinity change, even with time going by, but not all the parameters were affected by with the time going by. Also, the cycling hypoxia has stronger impact than the salinity, because a higher salinity will not affected the HAMSAT significantly. Next, as for the recovery period, HAMSAT mortality and reactive oxygen species cannot be back to the normal standard and still higher. And next, the THC in their cycling hypoxia group increased in higher salinity water, showing the hypoxia adaptation. Because if bio into hypoxia water, they will improve their HAMSAT count to respond to the hypoxia. And next, but the rest parameters of HAMSAT recovered well. And next, therefore, as we can see, the short-term recovery is benefit to the immunity of the oysters. Also, next, please. From the table, we can see a short-term recovery can have a positive effect on the campsite, but the HM and the THC is still affected by the two factors and also affected by the interactions of the two factors. And RS was also still affected by the two factors, but they are not. RS was not affected by the interactions between the hypoxia and the salinity change. And next, all in all, in our opinion, first, the dicycline hypoxia and the salinity change have a bit weak impact, we think, on the ham site immunity of the Hong Kong oyster. But apart from the antioxidant stress and death of ham sites, because the HMLS was difficult to recover. And for the oyster had a higher HMLS and a lower THC, ESD, and LS or under dicycline hypoxia and salinity change. And thus, oyster showed pretty recovery to dicycline hypoxia and water salinity change after a 3-day shortened recovery. And next, please. This study gives some insights and reference to the oyster culture, and it is confirmed that we think the hamset mortality and the reactive oxygen species should be two useful biomarkers under some natural stress that like the salinity change and hypoxia. So maybe the next study can use the two parameters to do some studies, and that's all. Thank you very much.
Thank you, Ms. Jie, for your interesting presentation. I would like to invite one or two questions from the audience due to the time constraints. Are there any questions from the online or floor also? Okay, if not, I have one question. Have you ever tested the oyster size and weight after the experiment? Because of the in your data, the oxygen level and also the salinity clearly impacted the oysters' immune responses. So in that case, maybe their size and weight can be changed. So have you ever tested that kind of stuff?
In my PPT, here are some basic parameters about the oyster and also the water. Could you please show the PPT slide? For the results, the first, there are some basic parameters about the oyster for my PPT. The results, the first slide.
Okay, thank you. If there is any more question, thank you very much, Ms. Jie. Now we're moving on our next presentation. Our next presenter is Professor Oleg Sheka from Far Eastern State Technical Fisheries University. Okay, let us welcome him with a big applause, please.
Thank you, Professor Moon, for introducing me. It's my pleasure to attend this forum and I want to thank organizing committee for invitation to make presentation. Climate changes occurring in recent decades on our planet have the most significant impact on countries located on the coast of the seas and oceans. As a rule, the economies of such countries are highly dependent on their ability to use marine resources. Therefore, any negative impacts on the marine environment and its inhabitants seriously affect the socio-economic development of coastal countries. Among the most alarming climate changes, one can note an increase in average annual and seasonal air temperature, an increase in sea level and heating of surface waters, which change the conditions for the habitats of marine organisms. Yes, thank you for switch the slide. This slide shows the average temperature increased more than 2 degrees in Russia for the period of 1936-2019. For the Pacific Russia, an average temperature growth was about 4% more this time. Last decade, the most significant seasonal growth was in spring. Next slide, please. Yes, I'm not sure that quality of video channel is very good, but we can see that the most significant increase in average annual temperature is observed on the coast of the Arctic Ocean, which already greets the melting of vast areas of permafrost, and as a result, the large amount of organic compounds entering the ocean with the waters of Siberian rivers. It's worth noting that for the high latitude coastal territories of Russia, there is a significantly greater increase in average temperature compared with the similar regions of Alaska and Canada. However, over the past 7 years, temperature growth on the coast of Alaska is marked by green color on this slide. This has accelerated significantly, mainly due to the winter-spring period. For the marine Arctic, the increase in surface air temperature over the past 70 years in winter was about 2 degrees, in summer less than 1.5 degrees. A decrease in the area of polar ice correlates well with this data. In 2019, in the Primorsky territory, the southern part of Pacific Russia, a significant increase in average temperature was observed in winter, almost 3 degrees, and in spring, more than 2 degrees. In Russia as a whole, the tendency to increase annual precipitation prevails. Over the past 25 years, there has been an average annual increase for precipitation by 7, maybe 8%. The main contribution in this growth was done in spring. In a number of regions of Pacific Russia and Siberia, the trend exceeds 5% over 10 years. Moreover, the highest growth rates of precipitation are observed here in winter and spring. Next slide, please. Well, this slide shows the changes in the air temperature regime that lead to such dangerous phenomena for coastal countries as rising sea levels and penetration of inhabitants from warmer seas into the local seas. Sea level in the Peter the Great Bay, it is a northern part of the East Sea, was stable from 1950 to 1980 and increased 2 centimeters for the last 30 years. Right side of the slide demonstrates this. However, due to mountain landscape, coastal landscape, and low population density, it isn't so critical for the Pacific Russia. Nevertheless, it can have a significant negative impact on port cities and coastal agricultural areas while maintaining this trend. Next slide, please. This slide must show the points of observation. 3 of them are located in the southern part of Primorsky territory, and 1 marked by a yellow color is on the northeastern part of Primorsky territory. Average water temperature increased half of degree in the Peter the Great Bay for this last century. It led to appearance of representatives of marine inhabitants from southern seas that may negatively influence on local marine fauna. During last decades, the subtropical migrants invaded in the East Sea due to the general global warming. In recent years, the frequent appearance of white sharks took place off the northern coast of Primorsky territory and even in southern Sakhalin Island and in the Tatarsky Strait. If early white sharks, inhabitants of the tropical and subtropical zones of the oceans, rarely appeared in these latitudes, now they regularly fall into the fishing nets and attack tourists. Next slide, please. To protect against negative consequences of climate changes and provide sustainable development for southern territories of Pacific Russia, the regional government, under support of federal government, implements actions that decrease pressure on environment. It is promotion of green technologies, construction of new facilities for industrial and human waste purification, environmental expertise of major regional economic projects, and transfer of regional power industry from coal and oil to gas. Next slide, please. However, all these measures are local in nature and cannot change global trends. These issues are cross-border. Therefore, decisions must be developed and implemented jointly by representatives of all countries in the region. The environment is experiencing a severe stress from intensive economic development. This is especially evident in the Asian region, which in the recent years has become a driver of the world development. The increase in average annual air temperature, global warming due to the atmospheric pollution by greenhouse gases, uncontrolled anthropogenic impact on nature led to an increase in the number and intensity of natural disasters occurring annually, an increase in the sea levels, and as a result, a particularly severe destructive effect on coastal territories. The preservation of the existing dynamics of development will lead to even more significant economic losses in the East Asia for the next 30-50 years. The suspension, even for a short-term period, of the intense and negative anthropogenic environmental impact that occurred in many regions of the planet due to the spread of COVID-19 demonstrated that nature is able to recover quite quickly. Everywhere there is an improvement in air quality and a decrease in the amount of greenhouse gases in the atmosphere. All this shows that the point of no return has not yet been passed. If we want our planet to be a comfortable home for future generations, urgent measures must now be taken to prepare the programs for the sustainable development of regional communities. It's critically important that representatives of the scientific community from different countries participate in the development of such programs, which their subsequent approval at the governmental level. It seems reasonable to initiate a program for the sustainable development of the coastal territories of East Asia, which will include the necessary elements of environmental protection and rational nature management in the Western Pacific. Our countries have successful experience of implementing these kinds of the projects. In 2002, 4 countries, Russia, Republic of Korea, China, and Mongolia, carried out a major project, a Northeast Asian Strategic Action Program to protect transboundary biodiversity and international water resources and to attract green investments. This project, at the first stage, funded by a government of participating countries, later gained support of the global environmental facilities and the United Nations Development Program. The funding in the amount of $5 million was provided for preparation within the period of 2 years of the Strategic Action Program for protection of biodiversity, international water resources, its coastal regions, and important ecosystems of Northeast Asia. Final documents were submitted to the governments of the participating countries and funding agencies. Far Eastern State Technical Fisheries University is involved in implementation of major regional projects and provides scientific expertise and recommendations for sustainable development, including fisheries, aquatic culture, seafood production, and marine environmental issues. AMFUF participants have enough experience and skills to develop a large-scale project that will be very useful for regional development. Thank you for your attention.
Thank you very much, Dr. Shika, for your interesting presentation. I would like to invite one question from the audience. Are there any questions? Okay, if not, so we clearly show that the impact of the climate change can be happened not only the Taiwan but also the Russia area, and also it is the global issue. So, Dr. Sheka, I have one question. So, could you a little bit detail introduce about what kind of effort to do the Russian government for suitable development against the climate change?
Okay, thank you for your question. It's a very important question, discussed at many levels, government level, regional level in Russia, including Oriental Economic Forums finished in September in Vladivostok. The global and the most important goal is to move economy, first of all, power industry, from traditional gas and coal use to green power industry. At the first stage, it's important to change coal and oil on gas for our power station. In Primorsky territory, in Russian Far East, this process started about 7-8 years ago. And now we try to remove coal power plants, oil power plants, and to build new facilities for gas power plants. The next challenge is to move from traditional hydrocarbon energy power industry to green industry. This is wind, maybe hydro energy power plants. And the next challenge, this is hydrocarbon neutrality. We are at the start of this way, and our pilot project is realized in Sakhalin Island. The government of Sakhalin Island has a very challenging task to reach hydrocarbon neutrality in the next 5 years. If this project will be successful, the experience of this project will be distributed over the whole Russian Far East. Thank you.
Thank you very much. Okay, now we moving on our last presentation. Let's invite Ms. Ling Lin from Shanghai Ocean University. The presentation is entitled Study on the Dinoflagellated Sites in Ballast Tank Sediments of International Vessels in China Shipyard. Let us welcome her with a big applause. Thank you.
Okay, thank you. Can you hear me? Good afternoon, everyone. I am Lin Lin from Shanghai Ocean University. I am grateful for the opportunity to present my research. The subject of my presentation is study on the dinoflagellated sites in ballast tank sediments of international vessels in Chinese shipyards, and my supervisor is Professor Wu. Next, please. This is a quick outline of what I am going to talk about this afternoon. I will give a quick introduction and background into my research, followed by a summary of some shortcomings of completed research. There will be a look at the methods of analysis used as well as the results so far, followed by a look at future research. Next slide, please. Next, when considering the ship traffic, there are many different problems that can be looked at. For example, ballast water and sediment discharged by vessels have been the primary vector in the water transportation and the introduction of non-indigenous marine species to ports. The transfer of harmful and toxic dinoflagellates while ballast tank sediments from port to port has also contributed to an increase in the number and frequency of paralytic shellfish poisoning occurring globally over the last several decades when appropriate environment encounter. Dinoflagellates can resume their life cycle and form nutrient cells in the upper water body. This may trigger harmful algal blooms. This is just a quick mention of some of the published studies in relation to dinoflagellates in ballast sediments. Next, please. China is a major ship country. It is estimated about 17% of the global ballast tank sediments are discharged in China every year. The vast majority of past research has only considered the occurrence of dinoflagellates in the sediments of ships' ballast tanks in Xiamen and Dalian, and basically not looking at Shanghai port as an international shipping center. Next, please. The aims of my research, firstly, to determine the species and abundance of dinoflagellates in ballast tank sediment from 17 ships stored in Chinese shipyards, focusing on toxic species. Secondly, to examine the differences in composition of dinoflagellates among ships sailing different routes. Finally, to discuss the correlation between sediment water content and seas abundance, all of which will be discussed a little more in a few minutes. Next one. Next. This session looks at shipyard location and sediment sampling and analysis in comparison with shipyards in Shanghai and Fujian province. Deposit sediments in ballast tanks were sampled from 17 ships during their jaw docking. Samples were collected from the bottom of the ballast tanks, 5 kilograms of bottle sediment with spade into sealed bag. Sample analysis consists of the 6 steps shown in the figure. Next, please. Next, this slide showed that information about ballast tank sediment was collected. Next slide, please. This session looks at the results. It consists of 3 parts. This figure and the one on the next slide give a good insight into composition of dinoflagellates in ballast tank sediments, including harmful and toxic species. A total of 22 taxa were identified in the ballast sediment samples. These included 9 potentially harmful and toxic species, which are marked with an asterisk in Figure 1. When assessing the species variety of dinoflagellates, it was observed that the number of taxa was slightly greater in ships sailing short voyage. Next one. Next. This slide shows that there are differences on species composition of dinoflagellates. The comparisons of dinoflagellates in samples from ships sailing diverse routes were more variable than those sailing same routes. For example, the distance between ship 5 and ship 7, which sailed the different routes, was longer than that of ship 2 and ship 4, which sailed the same route. This implied that the types of dinoflagellates identified in sample ship 5 and ship 7 were of greater differences. However, differences on dinoflagellates type were also observed in samples from ships sailing same routes. For example, ship 8 and ship 12, both sailing China-Singapore routes. The difference on size groups was significantly influenced by the heterotrophic dinoflagellates. Next, please. Dinoflagellates abundance and its relationships with moisture content of sediment are shown on this slide. Total concentrations of dinoflagellates were significantly different among ballast tank sediment samples. The results revealed that the abundance of heterotrophic dinoflagellates were higher than those of autotrophic type for 40 ships. The correlation between sediment moisture content and abundance of dinoflagellates was analyzed. The results showed that the number of dinoflagellates present in sediment samples was positively related with the moisture content. At this section, I shall stop here. Now, let's turn our attention to the next section. Next one, please. Next, this part is a discussion of the results. First of all, the interpretation of differences in composition and abundance of dinoflagellates by sailing routes. The variety and types of dinoflagellates in ballast tank sediments from different ships is considered as a result of the ballast water management regulations implemented. The exchange frequency may also have impacts on the number of species and the concentrations of seeds present in ballast sediments. Secondly, the correlation between water content in ballast tank sediments and dinoflagellates abundance was analyzed. Sediments moisture content is related to the sediment particle size. Moisture content is normally higher in sediments with smaller particle size, as the proportion of clay is higher in such sediments. These are often accumulated better in viscous sediments with similar particle sizes and deposition behaviors, and thus can develop into higher abundance than in sandy sediments. Next one, the advantages of heterotrophic seeds were discussed again. Provincial study demonstrated that there were more than 2,000 species. Half of them were heterotrophic, while only few are strictly autotrophic. Photosynthetic dinoflagellate cells are generally sensitile. Massive mortalities may be incurred in ballast tanks during long voyages. In addition, diatoms as pre-organisms for these heterotrophic dinoflagellates are found to be abundant in the ballast water of ships. Finally, the harmful of toxic species was clarified. Harmful and toxic dinoflagellate seeds can form seed banks in the bottom sediments, which are the sources for the spread of harmful algal blooms. The proliferation of these seeds has significantly influenced marine ecosystems and caused enormous economic losses to the aquaculture industry. It is now well recognized that sediments in ship ballast tank sediments become a potential transport mechanism for the global transportation of toxic species. Next, please. We have discussed many points today. Let me quickly summarize the principal points. Firstly, the present study revealed that dinoflagellate seeds widely occurred in all samples of ballast tank sediment collected from 17 ships docked into Chinese coastal ports. Secondly, the concentrations and variety of dinoflagellate seeds vary among ships with different sailing routes and sediment properties. Finally, most important finding in this study was that harmful and toxic seeds representing a possibility of enormous biological immune risk were identified in collected sediment samples. Okay, that brings me to the end of my presentation. Thank you for listening.
Thank you very much, Ms. Ringni, for your interesting presentation. As you guys know, the ballast water and ballast sediment can be transferred without any barrier of the countries or continents. So not only the harmful cyst, but also the antibiotics resistance bacteria or other the transposable drug gene elements and the environmental hazardous species can be transferred from one country to other countries. So it is a really big issue nowadays. I would like to invite one or two questions from the audience. Are there any questions in the online or the floor also? Okay, if not, I have one question, Mr. Lin. In ballast water, we have the powerful disinfectant system using the plasma, UVC, or heat, and so on. This kind of the harmful cyst from the ballast sediment can be controlled. This ballast water disinfectant system, or do you have any idea about this kind of the technology or something?
Sorry, I'm not sure if I understand your question. Could you repeat your question?
Oh, okay. So for the ballast water disinfectant, we have a powerful disinfectant system for the ballast water, right? We use plasma or UVC heat. So this kind of the stress parameter can be disinfected ballast water. So in your presentation, you mentioned the harmful cyst can exist in the ballast sediment. So this kind of ballast water disinfectant system can be controlled the ballast sediment as well.
Oh, okay. Ballast 就是ships need ballast water carried in ballast tanks to provide stability and maintain safe transit conditions when sailing without cargo or only partially laden. Ballast tanks may also carry sediments that can contain variable organisms, including microalgae, bacteria, resting algae, and dinoflagellates. Ballast water and sediments discharged have been the primary vector in the worldwide transportation of introduction of no indigenous marine species. Current estimates suggest that almost 2/3 of global trades are brought by ships, and annual volume of ballast water required for global cargo transport is approximately 10 billion tons, containing 7,000 marine species arriving around the world. A wide variety of organisms may establish that in new environment when being discharged together with ballast water and sediments and becoming invasive alien species to the receiving environment.
Okay, thank you.
Thank you.
Okay, thank you very much, Ms. Ringni. Now, this is the last presentation today. Our last presenter is Mr. Pan An-duan from Korea Maritime and Ocean University. The presentation is entitled A Preliminary Study on Safety Zone of the Ship-to-Ship LNG Bunkers in the Port. Okay, the floor is yours, Mr. Pan An-duan, please.
Thank you very much, Chair. And my name is Dương Phan Anh from the National Korean Maritime and Ocean University. And today I would like to present our plenary study on safety zone of ship-to-ship LNG bunkering in port guarded person analysis. Next slide, please. As for background of our study, we know that environmental is a very sensitive matter of the world. So the International Maritime Organization has adopted many strictly regulations on the emission control. And this is a fork to the maritime industry to the new alternative fuel sources. And LNG is a very spotlight for this one. And you can see the figure that I took from the DNVGL, that from the 2000 up to now, there is an increasing chance of the LNG fuel ship, and it is predicted to the increasingly in the future. And next, please. And for the LNG fuel ships, LNG bunkering is really necessary. And there is three main methods for the LNG bunkering, include the ship-to-ship, the port-to-ship, and the truck-to-ship. And in here, we would like to mention about the ship-to-ship LNG bunkering. Because the ship-to-ship LNG bunkering now in South Korea and in the many other countries is in the first stage, and the regulation for the safety of the ship-to-ship LNG bunkering is not completed now. And this study is to carry out the consequent analysis of the determine the size of the vapor clouded person of leaks to prevent the worst-case incidents. Next, please. And we know that according to the ISO and the Classification Society, we have two main approaches for the determination of the safety zone, including the deterministic approaches, quality risk assessment approaches. And our CFD modeling is a very good reference because CFD modeling is based on the flammable limits of the fuel. And both of two approaches is also based on this one. And our simulation modeling is including the domination factors, including the ship size, environmental conditions, loading conditions, bunkering operation conditions as well. And we include with the leakage scenarios, include the leak hole size and leak rate, leak areas, leak duration, and we put on to our simulation case. And next, please. And in here, we use the FACT CFD software for the our case. And FACT use the the label stoke equation by the K epsilon turbulent model. And in here we can see the three main Gaussian equations for this one. And I would like to mention here our calculation of the nick rate through the failure of the bunkering host. It can be determined by the size of the nick hole size and the pressure inside the pinite and pressure inside the tank as well. Next, please. And in here, we would like to show, because of the presentation is short, so I would like to show the two cases of the changing the geometries of the ship side. So we would like to take the inference of the bunkering ship side to the vapor cloud dispersion. So, and this bunkering process is working under the effect of by wind and by some of the weather conditions. And in here, we set the wind speed is 2 meters per second, and ambient temperature is 20 Celsius. And there is an accident, and there is a nickage on the bunkering host with the nick area is 0.01 meters square, and nick rate is 5 kilograms per second. And our simulation time for this case is 30 seconds. Next, please. And we know that mass dependency is very important for the simulation. And in here, we use the K epsilon turbulent model for the mass dependency. And we just select the phi side of the mass, and we calculate with the x side of the mass, and we get the result from the x side. And in here, we can see if with the small side of the mass, so the result will be more good, but the computational cost and the time for simulation is higher. So in here, we balance between the many factors, and we choose the 2 meters of the grid size for our case. Next, please. And we can see in here the result from the K1 of our simulation. And in here, we see the changing of the color culture different. It means the difference of the pheromone concentrations according to time. And in here, we see the red one means the high density of the pheromone concentrations, and it will be reduced according to the changing of the color. And we can see in here that we selected 3 certain of time, 10 seconds, 20 seconds, and 30 seconds. So we can see that at the first time of the nickage, so the LNG is spring on the ground, and it will be contact with the air, and after that contact with the air, it receives the heat from the air and vaporize. So our simulation case shows that the density will be 10 to the increase after 20 seconds, and after that, the high density will be decreased, and the lower density will be increased. And the average diameter and height of this case we calculate at 98 meters and 19 meters and 11.5 meters in the X, Y, Z axis. Next, please. And for the K2s, we do the same methods with the K1, and we get another result of the 80 meters, 20 meters, and 9 meters in the X, Y, Z axis. And in comparison with the K1 and K2, we can see that the vapor dispersion behavior varies. And the lateral dispersion is net dominant compared with the K1 dispersion. And after comparison with the K1 of the LNG discharge in the above analysis, the vapor cloud is much denser on the smaller area of the total vapor cloud. And next, please. And in here, we can see the density distributions. So we would like to take the change, how the changing of the densities of the equal. So we get some of the monitoring point alongside of the vapor dispersion cloud. So we can see in here the first time of the dispersion is fluctuates so much of the vapor densities because it's under the effect of the pressure and the temperature outside. Next, please. And in here, through the 3D view, we can see the sharp change and the effect of the bunkering ship side to our 2K simulations. And next, please. And for our simulation, we would like to show that the simulation reveals that in 1K average cloud diameter is range from the 80 meters to 98 meters. And it has been found that the dispersion behaviors can be different due to the difference of the vessel dimensions. And I would like to mention in here that this is a preliminary study, so we just simplify our case. We use the box size for modeling our case, and we simplify some of the input parameters. But in the further work, we would like to show with the full size and the full geometries of the two bunkering ships, and we would like to take the real weather condition and real parameter in the port of the exactly port in the South Korean to our simulation case for this one. And thank you very much, and hope to receive some of the comments and questions from you.
Okay, thank you very much, Mr. Do, for your presentation. To be honest, as a microbiologist, your last presentation is the most difficult one to me. I would like to invite one or two questions from the audience. Are there any questions? Okay, if not, maybe it is the off question for your topic, but because of I'm not the specialist on this the major, but recently I heard that the hydrogen can be used as the ship fuel in the future, but as a microbiologist. Do you think in the someday the biofuel can be used in the ship as well?
Thank you very much for the good questions. Actually, our main research is based on the LNGs and hydrogens, but as far as I know that biofuels is very potential for this one, and we think that there is many alternative fuels, and each alternative fuel have its advantages, and our job to point out the advantages and how to use effectively of our fuels. Thank you.
Okay, thank you very much. If there is no more question, that brings us to the end of the session. I hope you will agree that we have had an excellent time, and I would like to thank to all speakers for presenting their tremendous work to us today. And also, I would like to thank the meeting organizer for their effort to prepare this on and offline system. Please enjoy the rest of the meeting and hope you see next year forum. Thank you very much.